Hello everyone, welcome back to our channel. Now in this video we are going to implement the algorithm that we are talking about so far in our try, which is the best one in which is one of the best questions as well in try, and also one of the very interesting algorithm in try, which is auto completion. We are going to implement this method find words where we will pass the prefix, and based on the prefix whatever words we have in our try, right, we are going to print them. Okay, now let's get into the implementation of the method. Create method. This is going to return the list of string, and this is supposed to be the prefix. Now to return the result, which is our output, we need a list of string, which I'm going to name as words is equal to new array list, and the same thing we are going to return. Now before we return this, right, we have to do two things for this one. First thing, we have to find the last node, because once you are able to find the last node for your prefix, right, from that node onwards you're supposed to check what are the words which follow that prefix, right? So to find those words which follow the prefix, first you're supposed to find that node itself. Once you're able to find that particular node, you can easily find those words as well. So that's all we have to do. So two things I have told you, right? First thing, finding that last node in the prefix, and second, finding the words which follow that prefix. So let me write the same thing that I have just told you. Get last node from this prefix, and we need our root node as well. And what is the second thing that I have told you? You will be implementing this find words method, because now you have your last node and you also have your prefix and you have your result, which is words. So these two methods is what you're going to implement in this one, and you will have your answer. So let's implement the first one. Get last node from this prefix, create method, try node. This is going to be the root and then prefix. Yep. So try node, let's take a current, let's take a temporary node named as current. Okay, now for each character in this prefix dot to char array, what you're supposed to do, you're supposed to get the child from that particular character, and then you can check if child is equal to null, you can return null there itself. You don't have to check for anything from there. If it is not null, then you will go ahead and continue your recursive call. You will make the current node as its child node, and this will keep on going, okay, until your child becomes null. And then once you're able to complete this loop, right, whatever the node you have in our current node, and that's what you're going to return. So this is going to return basically the last node from the prefix. What we are doing in this particular method, we have taken a current node, which is a temporary node. You have loop through the array which was created from prefix. You just kept on going to that particular node. You reach that particular last node from that particular prefix, and you have written that node. If your try does not have that particular prefix, you will be returning null there itself, okay, or else you are going to return the current node. So once you have the last node from your prefix, right, now you're supposed to find the words from that prefix. Okay, so I think we can write one more condition here. If prefix itself is equal to null, you can return null here itself, right? Now let's implement our find words method. Okay, Now what do we need here? Node, prefix and words. So if node dot is end of the word, basically this is the flag that we are using to mark the word as complete. So if this is true, that means this is a word. Okay, so what that means is that you are able to find that particular word there itself. So what you can do, you can add that particular word in your words list, which is actually the result for you. Okay, and you have added it prefix. Okay, else what you're supposed to do, for each of the child you can get the children from node dot get children. What you're supposed to do, for all of its children you are going to perform the find words, and you're supposed to collect those words. How are you going to collect? Now you're going to call this in a recursive way, this find words. You're going to pass your child node, then you can pass prefix plus child dot value, because once you keep on adding the value to the prefix, right, that is when we can add the prefix to your words array. If words array, and that is when you add your word to your list of words, and as a third parameter you can pass the words. That's it. For the null condition, if this node is equal to null, you can return there itself. There is your implementation for the auto completion. What you did, you have written this find words method, which is returning a list of string. You are able to find the last node from the prefix. Okay, and this is the logic to get it. I have already explained you. Once you're able to get the last node, you have created one more method which is taking this last node, this prefix, and the result, which is going to be your output. There you are checking if the node dot is end of the word is true. Basically that means that is a word present from that prefix, so you're going to add it to your result. Otherwise, for each of the children from that particular node, you are going to run this method in a recursive way. You keep on adding the child value to your prefix. Okay, and that's how you get your auto completion. Now let's check if the logic that we have written is correct or not. So I can see I have already removed one can, so we are supposed to get this cat and cap. Okay, we are getting those two words because we have already removed this can, right? That's why you're not getting this can. Our logic for the auto completion is working perfectly fine. Trie is actually really interesting. There are so many applications of Trie. Maybe in future we'll be learning about them as well. But for this video, that's all I was going to explain, and see you in the next one.